Hey everybody, and welcome back to FrontendExpert. In this video, we will be going over data structures in JavaScript. Now, to be clear, the goal of this video is not to teach data structures. If any of the data structures we go over are something you're not familiar with, I'd recommend checking out the data structures crash course on AlgoExpert. But the purpose of this video is to go over how to use some of the most common data structures in JavaScript. If you are going through a front-end interview loop, it's likely that you will actually have a data structures interview. And in that interview, if you choose to use JavaScript, you'll want to know how these data structures work. So let's start with stacks. Now, we don't have a stack data structure in JavaScript, as in we don't have a stack class that we can instantiate. However, we can actually just use an array as a stack. So we can say const stack and set this equal to an empty array. And then if we want to push onto the stack, we can simply say stack.push and whatever value we want. So maybe we push a 1, as well as we do stack.push the number of 2. And then if we want to get the values out of the stack, we can simply say console.log stack.pop. And remember, a stack is going to be last in, first out. So when I run this code, we get the number 2. Because of the fact that we popped out the number 2 as it was the last element added to the stack. And similar to stacks, we can also use arrays for queues. So we can say const queue and set this equal to an empty array as well. And now a queue is going to be first in, first out. So we will also use the push method. So we can say queue.push. Maybe we push 1 and 2 again. So queue.push of 2 as well. But we want to remove from the other end than what we did with the stack. So the way we can do this is by using the shift method. So we can say console.log queue.shift. And shift works the same way as pop. The only difference is it is on the other end of the array. So we can save this, and you'll see we get the number 1 because 1 was added first, and it is first in, first out. Now it is worth noting that the shift method in most implementations is less efficient than the pop method. So if you can use either shift or pop, you should be using pop. In some of the original implementations of JavaScript, shift was actually a linear algorithm, so it was O of n, as opposed to the O of 1 constant time complexity that we usually expect for the ability to dequeue from a queue. That said, with most of the modern browsers, you don't need to worry about it as much. However, if this is going to be an issue for you, then I would recommend using a linked list instead of using an array for a queue, but most of the time we are safe to just use an array and it will be much simpler. Okay, so next let's move on to maps or dictionaries as they are referred to in a lot of languages. So there's 2 different options for a map. First, we can use a traditional JavaScript object as we have seen throughout the crash course, or we can use the actual map class. So to instantiate a map, we can simply say const map and set this equal to a new map. And now to add a value to the map, we can simply say map.set and we pass in a key and a value. So for example, I can say test and I will set the value to be 1, 2, 3. And then we could also add another key value pair. So we can say map.set, and it's worth noting that we don't need to use strings here. So for example, I could set the number of 10 to be equal to, let's just say, the string 10. So the keys and the values do not have to have the same types, and we can use any types versus when we use an object, we can only use strings or symbols as the keys. And now, of course, to actually get the values, we can simply use the get method. So I could do console.log map.get, and we could get, let's say, 10. And when we run this, you'll see we log out the string 10, which is the value for the number 10. We can also get the size of the map by doing simply map.size. Now this is not going to be a function, it is simply a property. So we can run this and we get the number 2 because there are 2 elements in the map. We can also check if a value is in the map. So for example, I can say map.has10, and this is going to be true because 10 is a key in the map. However, if I did the string 10, we would get false because the string 10 is not a key in the map. It's also worth noting that if we say added an object to the map, so if we did map.set and the key was simply an empty object, and maybe the value was 42, and then we check if map.has an empty object, we're still going to get false. The reason being that these are different objects. We could, of course, make them the same object by doing const obj and setting this equal to an empty object, and then we could replace both of these with obj, and now because they are the same object, we would get true. So essentially, objects are being checked by references. Are they the same object, not just the value? It's not converting that object to some primitive and checking the value. It is checking, are they the same? Okay, but I will remove these two lines, and next we can also remove elements from the map. So we could do map.delete, and then we pass in the key. So for example, I could delete the key of 10, and now if I did map.has of 10, we would get false because 10 has been removed. However, test is still in the map, so this is going to be true. We also have a clear method, which removes everything from the map. So we can do map.clear. And when I run this, we get false now because test has been removed from the map. And we can check that everything has been removed by checking map.size, which is going to be 0. Okay, but I will remove this code. And next, I want to look at how we can iterate through the map. So we have a few ways we can do this. First of all, we can use a for of loop. So we can say for, and the value is going to be an array with a key and a value. So we can say array key value to get the key and value as individual identifiers. And then we can say of map. And then we can simply use this like a normal for loop. So we can say console.log key and then value, for example. And this will log out all of the keys and values. So we have test is 1, 2, 3, and the number 10 is 10. And similar to the for of loop, we can also use the for each loop function of the map. So we can say map.forEach, and this works essentially the same way as it does on arrays. So it's going to have a callback function, and this callback function will take in the value first and then the key. And then inside of the function, we can use that key and value. So we could do console.log key value, and this is going to log out the same thing we had above. It is essentially doing the same exact thing. And now lastly, we can also get an iterator from the map. So we can delete all of this again, and we can do const iter, and I will set the iterator equal to map.entries. So entries returns an iterator that we can use. And now, for example, we can do console.log, and we will log out iter.next.value. And we can run this code, and you can see we log out the first key value pair of the map, which is test and 1, 2, 3. And we could then just keep doing this. So if I had, say, 2 more of these, then we would log out, first of all, test and 1, 2, 3, then 10 and the string 10, and then we get undefined because the last iter.next had no more key value pairs in the map to log out. And now if you only need the keys or you only need the values, we also have functions for those. So we could also do map.keys, and this would just get the keys, or we could do map.values, and this would just get the values. Okay, but now the question is usually, when should I use a map versus an object? And oftentimes it doesn't matter too much which one you use. There are many times when either would be an appropriate choice. That said, there are times when it does matter. So for example, if you need a key that is not a string or a symbol, you need to use a map. There's no way around that. An object can only have strings and symbols as keys. Additionally, if you're concerned about iterating through the map in the insertion order, you will want to use a map. The map is always going to be kept in the order that the elements were added to the map. And on the other hand, although objects do have an order to them, it's usually not recommended to rely on that ordering. But then on the other hand, there are times when you need to use an object. First of all, if you just have something very simple, it can be a little bit quicker to instantiate an object. Additionally, if you are sending the object to the server via JSON, you are going to need to use an object because a map is not serializable to JSON, to the JavaScript object notation. And finally, if you need to manually be setting a prototype chain, so you need inheritance, you will want to use an object for that as well. And now one final component of maps that I did want to show is if you do have data that is already in arrays in the format that we tend to get when we iterate through the map, then we can actually pass those into the constructor as a way to instantiate the map with values. So for example, in the new map constructor, we can pass in an array. And this array is going to be a two-dimensional array, with each array in the array being a key value pair. So this first array, we can pass in test and 1, 2, 3. And then we can add a comma and add another array. And this one can be the number 10 and the string 10. And then we could delete this code here, and we will have the same map. So I can run this and nothing is changing. All we did was instantiate the map with the values already in it, instead of adding the values after the fact. Okay, so next, let's move on to sets. Sets are very similar to maps. A map is simply a key value pair with the keys being unique, and a set is just a set of unique values. So you can think of it essentially as a map where we aren't even worrying about the values, we just have a bunch of unique keys. And because they are so similar, they do have very similar functions, and they work very similar to each other. So we can delete this code, and we can say const set, and I will set this equal to a new set. And now to add to the set, we can either do set.add and maybe add 1, 2, 3, and set.add of 4, 5, 6. Or we can also add to the set by passing in an array to the constructor. So we could pass in the array of 1, 2, 3, 4, 5, 6 like this, and that would do the same thing. But for now, I will just use set.add. And now there's no get method because there's nothing to get, there is no value, but we can check if an element is in a set by doing console.log set.has, and we pass in whatever the value is that we are looking for, such as 1, 2, 3, which is going to be true. However, 1, 2, 3, 4 would be false because that number is not in the set. And just like maps, if we have an object, so if I did set.add of some object, and then we check if set.has that object, it is going to be false because these are different objects even though they have the same values. Next, we can also delete elements in the same way as maps, so we can do set.delete 1, 2, 3, and then we could check if the set has 1, 2, 3, and it would be false. We can also do clear, so just like map.clear, set.clear removes any elements from the set. And we can also iterate through the set in pretty much the same way as we do with maps, so we can use a for of loop. So we can say for value of the set, and let's just do console.log the value. And when I run this, you will see we get 1, 2, 3, and 4, 5, 6. And then, as you might expect, we do also have a for each function. So we can say set.forEach value, and all I will do is log out the value. So we can say console.log value, and we will once again get the same numbers. And then finally, we also get an iterator. So we can say const iter, and I'll set this equal to set.values. And then we could simply do console.log iter.next.value, and we would get the first value in the set. Now with a set, we usually just use this values function, but we can actually still use entries and keys. So if I did set.keys here, we would still get 1, 2, 3, so it's essentially doing the exact same thing. Or we could do set.entries, and we would get 1, 2, 3, comma 1, 2, 3. So you can essentially think of these set iterators as like iterating through a map, only the values in the set are the same thing as the keys. Now, one useful way to use a set in JavaScript is to remove duplicates from an array. So because sets don't have any duplicates, one thing we can do is we can create an array first. So let's say const array, and I'll set this equal to the array 1, 2, 2, 3, 4. So this is just an array with 1 through 4, but it has 2 copies of the number 2. But then if I wanted to get the array without any duplicates, what I can do is say console.log, and I'll call array.from, and array.from takes in some iterable and converts it to an array. And what we're going to pass into array.from is going to be a set. So we can say new set, and we will pass in the array as the parameter to the set constructor. So it is creating a set with these values. But because sets don't have duplicates, the set will remove the number 2, and then we create an array from that set, and because JavaScript sets maintain their order, we would get the same array, but without the duplicate value. So now we get 1, 2, 3, 4, and we have removed that duplicate. Okay, so now I want to talk about something known as a weak set and a weak map. So I will create a weak set, and this is going to be const weak set. I'll set this equal to a new weak set. And I will also camel case the S here just for consistency. And a weak set works just like a set. And the same thing is true for a weak map. A weak map works just like a map. However, there are two key differences. First of all, the keys can only be objects. So we can only add objects as keys to a weak map, and the values of a weak set can only be objects. So for example, if I did weak set.add and I just tried to add the number 1, 2, 3, we actually get an error because of the fact that we are trying to add the value of 1, 2, 3, and it will say invalid value used in weak set. So let's change this to be an empty object instead, and we can run this, and now we no longer have any errors. Okay, but now what's the actual point of a weak set? Well, the purpose is that the weak set doesn't prevent garbage collection. So traditionally in a set or a map, if you have some object, then that object cannot be garbage collected because there's still a reference to it. The set or the map is still using that object, so it cannot be garbage collected. But there are times when you want the garbage collector to still work as usual, and it should just be removed from that set or the map when it gets garbage collected. So that's how weak set and weak map work. If the object gets garbage collected, it is just removed from the weak set. So let me show you an example of what that would look like. So let's remove this weak set.add here, and let's create a scope. So I will do this using an immediately invoked function expression, but obviously there are many ways to create a scope. So we can say function like this, and then we will execute the function at the end. And let's say inside of this function, we had some object. So we can say const object is equal to an empty object, and maybe we did something with it in this function, but it doesn't matter what is in the object. And then we can say weak set.add the object. Okay, and now after this immediately invoked function expression is done, the object could potentially be garbage collected. In the case that this was a normal set, the object would not be garbage collected because it is still in the set. However, with a weak set, the object can be garbage collected because nothing is using it anymore, and because of that, it will be removed from the weak set. But this does bring me to one final point about weak sets and weak maps. Because of the way they are implemented, we actually cannot iterate through them, and there's no actual way to check the size. So I can't see what is inside of this weak set in any way at all. For example, if I did console.log of weak set.size and run this, we get undefined. So the only way to actually know if something is in the weak set is to use the has function. So we could do weak set.has an empty object, for example, and we would get false. We can't really check the obj here because of the fact that it is out of scope. But of course, if we put it in scope by simply commenting out this code, and then we check if the object is inside of the weak set, we would get true because we have added it to the set. But again, in this case where the object could have been garbage collected, there's no real way to see if it is still in the set or not, because in any case where it could be garbage collected, that means that we don't have any more variables that point to that object. Okay, so that's it for sets and maps, and really that's it for the data structures that are provided by JavaScript. So beyond that, any data structures that you want to use, you will need to implement using a class, or you will need to get from a library. And again, this video is not meant to be an instruction set on how to implement every data structure, so we're not going to go through all of them. They will all sort of follow the same format of using classes to be implemented in whatever way that data structure is commonly implemented, as that is fairly language agnostic. But to show an example of how this could work, let's implement a simple linked list. So I will delete all of this code, And we can start by implementing a linked list node. So we can say class node, and inside of this node, we will have a value as well as a reference to the next node in the list. So the most common way to do this is with a constructor. So we will create a constructor function, and this constructor can take in the value, and then we can simply say this.value is equal to the value, and this.next is going to be null initially. Okay, so now this is really all there is to a simple linked list, but if we did want a nicer wrapper class around it with some methods, what we can do is say a class of linked list, and then inside of this class, first of all, we want to have the constructor. So the constructor is simply going to create the head. So we can say this.head is going to be equal to null. Now, depending on what you need from the linked list, you could also set the tail to be null if you want to keep track of a tail, and you could also keep track of a size here if you wanted to do that. Okay, and now let's implement a couple simple methods for the linked list. So for example, what if we wanted to add to the start of the linked list? So I will call this add start, and we will take in a value. So then what do we need to do to add something to the start of the linked list? Well, first of all, we need to create a node. So we can say const node is equal to a new node with the value. And next, we need to set the head to be this node. So we can say this.head equals node. But then we need to set the next value of the new head to be equal to the previous head. So we are going to need to save that head before we do this. So we can say const temp head is equal to this.head. And then after we reassign the head, we can simply say node.next is equal to the temp head. We could alternatively do this in a little bit simpler way if we are clever about reordering the code. So what we can do instead is up here above the this.head line, we can simply say node.next is equal to this.head. And because these are references to objects, we are setting node.next to be the current head, and then we set the head variable, not the head node itself, but the variable of this.head equal to this node that we just created. Okay, so that should do it for add start, but then what if we wanted to add to the end? Well, we could say add end, and we can take in a value here as well. And I will scroll down to get a little bit more space. And then what do we need to do in add end? Well, we still need to get the node, so we can say const node is equal to new node with the value. And then we need to iterate through the entire linked list and add the node to be the last value. So we can create a cur reference by saying let cur equal this.head. And now there is an edge case where the head is actually null. So we can say if cur is equal to null. So if we have nothing in the linked list currently, then all we need to do here is say this.head is equal to the node. And then we also want to return just to end the function here. And now the alternative is that we do have a cur and we want to iterate to the end of the list. So we can say while cur does not equal null and cur.next does not equal null. So essentially we iterate until cur.next is null. And once cur.next is null, we know that cur is now the last element in the linked list. And to do the actual iteration, we can simply say cur equals cur.next. And finally, once we have found the last element in the linked list, all we need to do is say cur.next is set equal to the new node that we created, which is going to be node. Okay, so now let's come down to the bottom here and actually try using our linked list. So we can say const list is set equal to a new linked list. And let's start by adding some elements to the start. So we can say list.add start, and let's add the number 1, and let's do list.add start and add the number 2. And then we can also add to the end. So we can do list.add end and maybe add the number 3 to the end. And to actually get these values, we could start by saying console.log of list.head.value, and we will see that the head value is 2. And this makes sense because 2 is the last element that we added to the start. And then we could also do list.head.next.value, and this is going to end up being 1. And this makes sense again because we added 3 to the end, whereas we added 1 to the start, but that was done before we added 2 to the start. And then we could also do .next one more time, and now we would get 3, which also makes sense because 3 was added to the very end. And of course, if we did .next here, we would simply get null. Okay, so that's sort of the basics of how you would implement a linked list using JavaScript. Again, this wasn't meant to teach the data structure, just to show how to implement it. If you are interested in learning more about linked lists or any other data structure, I do once again recommend going to the data structure crash course on FrontendExpert. And finally, any other data structures, such as one of the various types of trees or graphs, you could implement using a class, very similar to how we implemented this basic linked list, just following the standard protocol of how that given data structure that you need is usually implemented. And with that, that will be the end of this video on data structures in JavaScript. I hope you enjoyed it and I hope you learned something new. I'll see you in the next one.